My name's Lee Evans. I'm an OHDSI collaborator for the last 3 years. One of the things that I have been doing is deploying the tools in a number of organizations. And as we did that, it became obvious that the process to install the Web API, Atlas, it's kind of a lot to go through. And we heard earlier that people have gone through that situation, even given up in one case. So what I did was I looked around for technology that was available to make it easier to deploy. And this was probably about 2 years ago. And so around that time, Docker was becoming quite well used, well known, and certainly it's accelerated in its acceptance. And Docker is a container technology which allows you to basically package an application and all of its dependencies in a single image. People get upset when you call it a sort of miniature virtual machines. I'm not going to call it that, but it is. It's basically a Linux kernel, a little bit of operating system, and all the files and application services that you need to run your application. So with Docker, there's a way of building your own Docker container, Docker image. There's a Docker file that you use. And I'm not going to go into that and how we build this particular container, but one way to show is how we can use the container to get these tools installed much more easily and much more quickly. So let's just talk a little bit about what this is. So we called it Broadce. So everything has to have a name, and there's always Greek gods involved. And, I like Broadce because it's a little bit of a play on Docker, because it's on the water, and the idea is to spread the ability to use these tools as widely as we can. The definition for the container is all open source, and it's out there on GitHub. So if we go to the OHDSI repo, there is a Broadce repo there. This is kind of the high level of how to use Broadce. And there's two different containers. One is there's a web application, which is Atlas. Whoop, let me go back. Yeah, so there's the RStudio container. So if you need to run R, which you probably would want to do if you have Atlas even, because you're going to generate R code. There's one container for that, and there's a separate container for the web tools, which is Atlas and Web API itself. So these containers, they encapsulate all of the tools, and they allow you to then script the runtime, so you can pass parameters into those containers when you start them up. And the way we do that is using something called Docker Compose. And Docker Compose is just basically a script with environment variables. So I'm just going to show you what that looks like. And so there's a separate script to run these containers under these directories. So for the person that was wanting to do this on Windows and on Oracle, this would be the place to go to get to that script. And within here, it's actually got information about the two containers. So one is the web tools, so that's Atlas and Web API. And then the other one above there is the RStudio. And that has the packages from OHDSI already built into RStudio, so you don't have to download anything else separately once you start the container up. And I maintain the web tools container, so it stays up to date pretty much with the latest release of Atlas. So I'm a little bit behind with the version that just came out, 2.2, but that should be available probably next week sometime, next week. So let me just go back. So I just want to cover at the high level, what is the advantage here of having Docker containers? Why are we doing it? So we're packaging up the application with all its dependencies. It's scalable, so you can run it on a laptop, all the way up to run it on multiple servers in a multi-server cluster. You can run it on cross-platform, Windows, Linux, OS X, and various clouds. As I talked about, we can script the runtime, so you can use Docker Compose, is what I'm going to demonstrate today. But you can also use things like Kubernetes, and you can define a pod definition for that runtime. And we've got 2 containers I talked about, so Atlas, Web API, Tomcat, and then the other one is our methods, our studio server. And you know, if once you get a copy of the slides, I did put a link on here so you can get to the information that I'm using today just for this demo as well. All right, so I think we should actually go through the process and see if in 10, 15 minutes we can go from nothing to having Atlas up and running and our studio up and running. So given that we're on Wi-Fi, and we'll see how well that works. But I cheated a little bit because I've downloaded some of the things ahead of time, and so they're cached. So we don't have to wait for a download of maybe a 1 gig container over Wi-Fi. And I'll tell you where I cheated, but it's not much of a cheat. It's the same commands that you're going to run. It's just that you would have to wait for the pieces to come down. All right. So this is, it's actually an EC2 Amazon server, because I found when I was downloading locally it was just super slow. So this was a vanilla Ubuntu server. So the first thing I would do is I'd have to go in here and I'm going to do my normal update. So I don't know if I can try and make it a little bit bigger. It's going to be hard to read, so I'll try and say what I'm typing as I type it. Let me see. I don't know. If I make it too big, I won't be able to type it that easily. All right, that may work. Okay, so the first thing I would need to do is install Docker. So Docker has its own engine. It's a sort of daemon that runs in the background, and it responds to the Docker commands that we're going to be typing later. So the first thing would be to install Docker. So I got Ubuntu. I'm installing Docker now. Install docker.io. And then as you did this, you would see that it would download lots of things. It would take maybe a minute or 2 to do that. And it's automatically going to start Docker running in the background, because Ubuntu is nice like that. It starts up services for you. All right, so the next piece is we're going to use this Docker Compose to be able to run the scripts with the environment. So we'll do, we'll install that next. Where am I? Oh, it would help if I can type. There we go. Very quick. And so with a Docker, so you have a Docker file, you create a Docker container, it produces a Docker image. And what we do is we push those images out to Docker Hub, which is a publicly available repo for Docker container images. So if you go out to hubdocker.com and you just do a search for Broadce here, you'll see the containers out here. And what we'll do next is we need to pull those images down to our local server in this case. So we're going to do a Docker pull and just specify the full information about those images to pull them down. So there's a couple of them out here. The official ones, the OHDSI ones are the ones that you would want. Interestingly, there's also a Broadce Shiny, which is pretty new. So if you want to run a Shiny server, that might be useful for other people to use as well. All right, we'll go back to our command line. And we'll do that Docker pull. And that long name of the container image that we want to download, we're just going to type that in. So we got Broadce methods library. Okay, now that's where I saved a lot of time, because that's 1.2 gig that I just pulled in, and it's cached locally because I did it earlier. That's a cheat, but just to be prepared to wait a couple of minutes at that step to download everything. It's not a problem if you're having to wait there. And then we do the same for the other container. Docker pull. OHDSI Broadce Web Tools. All right, again, it's another gig. You're going to have to wait for that step to complete normally. So what else do I have on here? I got one other file that I put on this server. That's the only thing I installed. I just copied it in. So let's just look at that. This is the script that's going to tell Docker how to start these containers up. I found out I can't talk and type at the same time. With one hand. Oops. You can? Okay. All right, good. All right. So this is the, as I said before, the GitHub repo for Broadce has example templates of these Docker Compose files for each of the database, the DBMSs. So what I've done here is just basically filled in this template with the information I need to connect to the database. So I did that earlier, but we can just walk through a little bit. So down here, Atlas needs to know how to talk back to the web API back on the server that's running. So you have to give it the URL. And I know ahead of time that this is the URL for this particular server. It could be a DNS name. It doesn't have to be an IP address there, but it's convenient. I'm using Postgres. So this is basically my database connection string I have to specify. And I filled this in. This is an RDS database I just created for this demo. So I've got, username. I've got a password here, which I don't care because it's a demo. But in reality, you would put that in something like Vault, or you would put it in an environment variable so it's not exposed. A quick question?
Quickly,
yep.
We talked about databases.
Yep.
And being able to split up and have the results database here and your source database in another. Is that in the template?
So this will connect basically to the database that has the OHDSI schema in it. And then within the OHDSI schema, you can put all the sources of your other databases. So it's like a level of indirection to get to there.
Thanks.
Yeah, sure. It's a little hard to wrap your head around it at first, but it makes sense. It's very flexible to do it that way.
Right.
Okay, and then basically we're just putting some more information like that around. We talked about Flyway, which is this technology that they use to update the OHDSI schema automatically. It's pretty cool, but it doesn't work on the results schema as was discussed earlier. All right. So that's it. I mean, I basically filled in the database connection information. I did it a couple of times because some of these parameters are required for that, and I'm done. So the next step would be I'm going to start those containers. So if I look right now, there's nothing running. So Docker PS, this is what's out there on the machine. I haven't run anything yet. So I'm going to do a Docker compose up. And -D just means put it in the background. And it's going to, when I do that, it's just going to look for a Docker Compose file. Let me just start it and I'll answer your question. So it's going to look for that Docker Compose file and start up both of those containers, because both of those containers are referenced, the RStudio container and the Atlas container. And now we can see both of those are running. So what was your question?
Is Postgres in the container?
No, so this is really, the Broadce is about putting the tools in containers. It's not really helping you with creating your CDM database.
So did Postgres have to be installed?
Yes, so I have an Amazon RDS service. I created a CDM database separately. Okay. So this is basically, if you've got your own CDM and now you want to put Atlas on it, this is the quick way of getting all those tools. And all we have to do is point them to your existing CDM. All right, so we're up and running here. Let's go see if, hopefully things are going to work. Let's see. All right, actually I want to look at RStudio first, because Atlas takes a little while to start up. And all I'm going to do is put the IP address of this server and the port, because it's run on 8787. That's why I cross my fingers. There we go. All right, so now we've got our studio running, and the packages, the Odyssey Studio packages, the Odyssey R packages are already in here, so I don't have to go through the process of installing Achilles, installing SQL Render, DevTools. If you look at the GitHub pages for those packages, there's a lot of dependencies there. The nice thing about this is that those dependencies are built in, and they get updated over time. So that's the one container up and running. You know, we could run Achilles in here now, pointing to the database, just specify a connection. Yep.
So, Lee, back to my original question, I could skip all of Frank's lengthy instructions about my configuration. I could just download Docker for the desktop and
yep, Broadce. Yep.
And it's going to be more foolproof.
Well, let's see if it's foolproof, because we've got to see if the other one's working, right? So,
I'll tell you.
yeah. So now we're going to go. Same server IP, different port. This is Atlas. And this is where I cross my fingers in. And there we go. Atlas is up and running. And just to prove it, we will do a quick, let's just put hard in here, which takes a while. And we'll just prove that. So Web API is running in the container. Atlas is running in the container. Tomcat's there. We're done. Okay.
So by just installing Broadce, we don't have to worry about the other dependencies.
That's right. Now, it's, you know, if you have to scale, then you might want to think about what kind of server you're going to be running on, and you know, you could be running multiple instances if you've got multiple teams. But for the basics of, you know, I just want to do some development, or I got a small group of people and I want to have access to Atlas and do some research, this is the fastest way to get up and running. Yeah.
So if you do want to do development either on the Web API or Atlas side, how do you get in and change code and keep it going in your Docker?
Well, there's one way you could do it is you can connect into your Docker container. So you can do a Docker exec and actually get a shell in there,
Okay.
and you can do that. If you're working, it depends what you're doing. If you're doing front-end development, you might just want a web API that you can work with. Then you can have it up and running in the background in a Docker container. So that's nice. If you're developing web API, then you're probably going to be running it within NetBeans or some kind of IDE.
I see. But if you're working on Atlas, you could also be running Atlas through the Docker container.
You could.
And then you could go in and SSH in and...
Yeah, essentially you can get a bash shell within the container. Or
But you probably, again, just want to get Atlas in your local...
I mean, if you want to get more sophisticated with it, there's a way of mapping volumes. So directories within the container, you can expose them to the host. So your source files can be on your host. You can edit them normally, and the Docker container will see them as if they're in the container.
And if you want to check those into GitHub...
I think we're getting way into it, but yeah, so it's valuable in that respect. But any questions on the process? I mean, did it seem like it's reasonable? We did it in 10 minutes. Now, I did cheat. The other cheat that I did, let me just own up to one last cheat. Let me go back to here. So there were two files here. Oh. When I go to Postgres, I showed you this one, but I avoided this other one, the source daemon. So this is what Frank was talking about earlier in terms of configuring the web API. There are a couple of tables, a source table and a source daemon table, where you have to specify, again, the strings for your CDMs. And so what the step that I skipped was I didn't go over to Postgres and run this SQL script just to update those tables. And the reason I didn't do it is because of Flyway. You kind of have to start, you start up the container, and then you go and that creates the source table for you and the source daemon table, and then you have to do the insert, and then you have to refresh. So it just was a little bit of extra detail there. But it takes 5 minutes to do it. So that was it. I mean, in terms of the demo of 0 to Atlas, I think we did it in 15 minutes. Does it? All right. So I thought, because we might have some extra time, that we could cover something else that's very new. That's also got the name Broadce, but it's more Broadce Api. And it's a beta, and it's something that's brand new. So I just wanted to introduce it to people and maybe get some feedback, get some interest, a level of interest on another way of accessing Web API and some of the, the cool technology from OHDSI through a services interface. So we're talking REST APIs.
Quick question before you get there. This is probably where people screw up more than anywhere else, I think, setting up this little file. So what would it look like if you didn't have it set up correctly? Where would you start to see, oh, this is breaking, but it's probably just breaking?
Yeah, when the container started up, if you looked at the log, it would probably tell you that it couldn't make that initial connection to the database. I mean, I think it's gotten better with the error message that tells you that now. So you go into the container log and find that. All right, so let's go back to the slide deck for a second. All right. How do I go full screen on here? Which is top right. I've been trained by PowerPoint over the years that things have to be in a certain place. So this is a little bit different version of the diagram than you saw that Frank presented earlier. But I just wanted to sort of show you what I'm introducing here. So this is something new. So what I wanted to do was enable people to contribute more easily. So one of the reasons I did Broadce as a Docker container was, again, to get more people access quicker to the tools. So one thing that's come up a few times is that if I just want to create a simple web application, I've got a lot of work I've got to do right now. I've got to get changes into Web API on the back end. I've got to understand how Web API works. I've got to understand all these connections here. So the nice happy path that everyone follows, which is great, is Atlas and Web API and the different databases that are supported. There's a lot of different databases now. So even Impala, Oracle, SQL Server, all these things are supported through the OHDSI technology. And a SQL render and database connector, data connector, really very cool technology that people just maybe take for granted, that we can connect to all these different database services, automatically translating the code. A lot of it due to my time. So this is how things connect. I know Greg's going to talk a lot about network studies and Arachne and the technology there. So I'm being very simplistic by putting this one little line here. But one way to show was, can we expose the Web API a little bit easier? Instead of having all the different methods available, and there's pages and pages of them at this point, can we just simplify things for people so we can just do some quick web development? And is there a way that we can expose our methods as services as well? And maybe Python, right? Because Atlas, at this point, it doesn't directly talk to R methods. It doesn't talk to Python, but it could in the future. So what I did was I'm hosting these pieces basically in the cloud on AWS. So we've got Web API as a Docker container. There's an R method that I'll talk about very quickly. No Python yet. And I'm also running a Postgres database. This is just a kind of proof of concept of how we could actually expose these technologies just through a web interface and make it easier for people. So what I've done is, if I go over to here, here's a quick demo, right? So I've got a very simple application. Oh, let me talk about the what I've exposed as a web service interface. So I just got two very simple things, right? I'm running an R method as a web service in a Docker container, and Iris is just very basic statistics about a whole CDM. And then I'm running a Web API in another container. I just want to expose the vocabularies, right? So let me see if I can find it. I'm just looking for the, I do not have it up here. Okay. So what I've done is put together a developer portal for an API. So we've got Broadce Api.org. And this is brand new. It's not pretty, but it's just it's a concept, and I was just interested in people's thoughts, so we can talk about, is there interest in this? So proof of concept, right? So these are the APIs available. You can go to this site. You can register. There's no cost or anything involved. It's talking to cloud services, running in Docker containers. So I've already registered. I can get access to this. Here's my API key. If I just want to test, I can go through here, put my key in, authorize it, and now I can actually run this service, try it out, right? So this service was that Iris basic statistics about, oh, we're not, you know why? I need to be over in the other, in Postgres, so I'm just going to do that again very quickly. All right. Go here, get my API key. Do a get. All right. We'll try that again. There we go. So what I did there was I went through the Broadce API service that I've set up, which exposes this Iris R function, and it gives me back the results of JSON. So then I can use that same function in a web application, right? I don't think I'm going to have time to show the web app. This is a very simple demo with a Node web server. But the idea here is that we can start to expose some of the web APIs, some of the R methods, as just simple web services that anyone can then access. Go to this site, get an API key, and you can start to develop your own simple web page if you want. So if it's just a simple form, you want to put some parameters in, call an R method, this is a new way of doing it. So. Any thoughts about, as I wrap up, is there any thoughts about, do you see some value in being able to expose some of the web APIs, some of the R methods as a service interface that's documented?
I think so, absolutely. So, like yesterday, the day before yesterday at the panel, I made a comment about scoring somebody, and GenReps created a Shiny app, I think yesterday, something like that. Calling an R method through an API so that another application can use it.
Right.
I think that would be fantastic.
Yeah, and this is like a sandbox. This is a playground that anyone can use. And if there are some things that we want to load up in Docker containers, just talk to me, contact me. It's evans@odyssey.org, and we'll see what we could build up together in here as a showcase of things we could build. So, thanks for your time.